All right, this is 11.4. It has 11.3 up there, but that's supposed to be 11.4. Areas of regular polygons. Okay, so we're going to look at how to find areas of regular polygons, okay, and what an apothem is. Now, an apothem is a segment that is drawn from the center of a regular polygon to one of the sides and makes a right angle with that side. So notice right here, that apothem going from the side to the middle of the circle, that's called the apothem. It forms a 90-degree angle. Okay. Now the area, okay, using apothem is 1/2 the perimeter times apothem, and that gives us the area of the parallelogram or quadrilateral. In this case, we're going to use a hexagon. Okay, notice 6 sides, 1, 2, 3, 4, 5, 6. Okay, so to do this, I have to do 1/2 the perimeter times the apothem. On a regular polygon, I know that all the sides are going to be the same. So 7 times 6 is going to be 42. So I'm going to have A equals 1/2 of 42 times the apothem, which is 6. All right, go ahead, plug that into your calculator, and you should come up with around 126 for the area. So this is just an easy way to solve for any kind of polygon. It doesn't have to be a hexagon. It could be anything else, like an octagon or something like that. Just know that the apothem starts at the center point right here and goes down to the side of the polygon and forms a 90-degree angle. All right, so the central angles of a regular polygon are congruent. All right, if you notice, all those angles coming off the center of the polygon are all congruent. So in the hexagon, each measure is 360 divided by 6, or 60 degrees in this example. Okay, so OG also bisects the angle AOB. So angle AOG is 30 degrees. So what this is saying is, because it says 6 sides, you do 360 divided by 6. And this angle here is 60. This angle here is 60. This angle here is 60. This is 60. And this is 60. All right. So if the apothem always is going to cut it in half, so this angle is 30. And if this is 30, know that this is 90, right? So that must mean this is 60. So when you have these problems, you can see that these are going to give you 30, 60, 90-degree triangles, and we're going to be able to use the ratios to find answers. Okay? So if we look at this one, since each side of the hexagon is 8, all right, that means AG equals 4. All right, so 4 is right here. All right. Then use trigonometry ratios to find the length of segment OG. So now if I need to find the apothem, I know the short leg is x normally, which is 4 in this case, so this is x. Remember that the hypotenuse is 2x, and the long leg is always x root 3. So that means OG is then going to be 4 root 3, okay? Or 6.99 if you plug that in your calculator. Got it? We know the area of a circle is pi r squared, okay? So if I want to find the area of the shaded region, if FD is a radius and hexagon ABCD is a regular hexagon, all right, how can I find this? Well, first I have to find the area of the circle. Okay, so the area of the circle is pi r squared, so it's going to be 36 pi. So let's just put area of the circle equals 36 pi. All right, so that's that. Now, in order to find the area of the blue region, I have to subtract the area of the circle by the area of the polygon. Okay, so 1, 2, 3, 4, there's 5 sides. So again, the area of the polygon equals 1/2 the perimeter times the apothem. So the perimeter, if there's 5 sides and each side is 5, the perimeter is going to be 25, right? So A equals 1/2 of 25 times A. So once we have the perimeter and we need to find the apothem, again, we're going to split these up. Okay, let me make this a little bit, let me get the eraser and make this a little bit better. Okay, so we're going to split all these angles up. There we go, it's a little bit better. And try to find what each of these angles are, okay, because that will help us. So I do 360 divided by 5 and I come up with 72. So this is 72. This is 72, this angle is 72, this angle is 72, and then this angle would be 72. But because we're trying to find the apothem, all right, we cut that in half. So this would be 36. If this is 90, this is 36, this would then be 54, right? Because they all have to add up to 180. So now that I have all the angles, I can solve for this because I can go back to SOHCAHTOA, right? So I have the opposite, I need the opposite side, which is x, okay? And I have the hypotenuse, so I have the O and the H, right? Opposite over hypotenuse. So my problem now is sine of 54 equals x over 6, right? So I'm going to multiply 6 times sine of 54. And I'm going to get right around 4.8. So I know the apothem equals 4.8. All right, so we can put that in here. So now to put this back in here now, so I'm going to put my apothem, which is 4.8, back into this original equation, and I'm going to have area equals 1/2 of 25 times 4.8, which then is going to give me 52.5. So I know that the area of the polygon is 52.5. So let's put area of polygon equals 52.5. So now I have to do 36 times pi, which is 113. Okay, so this is going to be around 113, and I subtract the area of the pentagon, which is around 61. So there I've found the area of the shaded region. So the homework is on page 795, 2, 3, 8, 9, 10 through 12, 15 through 17, 22, and 23. Please let me know if we need to go over this. I understand that this can be a little bit tougher. And then go ahead and start the next video.